Hi, Assalamualaikum. Before this, we have learned about the linear and quadratic equations. Today, we are going to look at the cubic equations. So, cubic equations is basically the highest power of x in that equation will be to the power of 3. Right now, let's just look at the concept of the polynomial. So, the polynomial is actually defined by this, what do we call, equation, this expression here, where we have a and x to the power of n. So this one is actually the polynomial to the power of n, right? Because the highest power of x will be n, right? So we have this one n minus 1, and finally we have a constant at the back there, and we have one condition that the coefficient of x to the power of n will not be equal to 0. So this one cannot be equal to 0, where n is actually a positive integer. Alright, so maybe you are wondering what type of function is this, right? So this is a polynomial function. Suppose we just consider the constant function. So what is it actually, right? So a constant function would look like, for example, you have px is equal to 4. Because we just have this part. The rest of this equation, alright, let me just highlight it here. The rest of this equation is actually 0, and we are left with this one only, right? So we have px equal to 4, so that is a constant. What about you have a linear function? So you have something like px equal to 2x minus 3, right? So we only have this part, all right? So we have this part only, so the rest of this part will be 0. And if we have the higher power, so we have the highest power of x will be 2. We have, for example, x to the power of 2 minus 2x plus with 3. Therefore, we have something like this one will be what do we call a2x to the power of 2, right? Before the a1x. So we have this part only. So this is actually a polynomial. And finally, we go to the cubic, which is the higher power. So we have the highest power of x will be 3. So x to the power of 3 plus with 4x squared minus 3x plus minus 1, for example. So this is the cubic equation. This is the part where we are going to discuss today, right? So this is the cubic equation, where the highest power of x will be equal to what do we call 3. All right. Now, all right, let's go to this one. We have a theorem saying that if px and dx are two polynomials, then we can write px is equal to the qx multiplied with dx plus with rx. So we can break this px break out into qx multiplied with dx plus with rx, where qx we call this as the quotient, right? Qx is the quotient, and dx is actually the divisor, right? And rx is actually the remainder. Right? Maybe you're wondering, right? After this, we'll see when will we use this px equal to qx dx plus with rx. When? All right. And we have another theorem saying that we call it as a remainder theorem. If we have the polynomial fx, when it is divided by x minus c, therefore we will have the remainder, which is given by f of c, where c is actually a real number. The second theorem is on the factor theorem. It is actually related to the remainder theorem, but we specify this for the case where fc is actually equal to 0. So when we have a factor theorem, so we can say that fx has a factor of x minus c, or indirectly we say that x minus c is a factor of fx if and only if fc is equal to 0. Alright, let's see when will we apply this theorem. Alright, for example, suppose we discuss on this division of x to the power of 3 plus 2x squared minus x plus with 10. We would want to divide it with x plus 3. We can use the first concept here. We want to use the method which is called as long division. So we can put in this, all right? So now we will divide. All right, so we consider this part first. So x to the power of 3 with x. So what will happen when we divide x to the power of 3 with x? We'll have x to the power of 2. Now you multiply back. so it goes this way. So x to the power of 2 multiplied with x will have x to the power of 3. X to the power of 2 multiplied with x, 3, we'll get plus 3x squared. And then this is kind of, you know, the usual division you have done before. Now you have a minus here. So x to the power of 3 minus x to the power of 3, you are eliminating it already. You have 2x squared minus 3x squared, you have a negative x squared. You bring this down, you have minus x plus with 10. Now you want to divide negative x squared with x plus 3. So what will happen? So negative x squared, you divide with x, so you will have a negative x. Alright, so when you have a negative x, you go back to this way. So negative x multiplied with x, so you will have a negative x squared. Another one, you have a negative x multiplied with 3, you will have a negative 3x. Right now, what will happen? So you have to minus here. So negative x squared minus negative x squared will become 0. Negative x minus negative 3x, this one will become 3 minus x, so you have 2x. To have 2x plus with 10, therefore now you have to divide again 2, right? You go back to this, 2 divide with x, you'll have a positive 2. A positive 2 multiply back with x, alright? So you go back this way, so 2 multiplied with x, you'll have a 2x, and 2 multiplied with 3, you'll get a positive, that one is a positive 6. All right. Now we have to simplify this. Again, we have to minus 2x minus 2x, we get 0. 10 minus 6, we get a positive 4. Therefore, now we can highlight this part. This part is known as the quotient. This is the divisor, and this is the remainder. Right? So we can say that, okay, we have this, what do we call? Okay, in this case, px is the initial equation where we write x to the power of 3 plus with 2x squared minus x plus with 10. Right, in this case, you get qx is actually one at the uppermost there. So we have x squared minus x plus with 2. And then you have the divisor, which is dx, in this case x plus 3, and the remainder rx is actually a positive 4. And then if you want to make a relation, so you can write px as, right? So I'm going to write px as qx multiplied with dx. So this is actually x squared minus x plus with 2. I have x plus with 3, which is the dx. We plus with the rx, so in this case we get plus with 4. Because we have the px, which is equal to qx multiplied with dx. This is plus with r of x. Right? And if you want to use the, what do we call, the remainder theorem. So we know that when we multiply, when we substitute with fc, so we know that x minus c, we know that it is actually the remainder of fx. So in this case, we know that the remainder is actually 4. Suppose we want to use the remainder theorem. So if we want to use the remainder theorem, so we just need to consider, because this is the divisor, so we need to consider f of this one is positive, so it will become a negative 3. If we try to substitute with negative 3 at the variable x inside the initial function, which is px, or in this case I call it fx, what will happen? Alright, so I want to substitute negative 3 inside this. So this will have a negative 3 to the power of 3 plus with 2, negative 3 square minus 3, minus a negative 3 plus with 10. So I will get this one as a positive 4. I'll get this one as positive 4. Alright, so we know that when you have this polynomial and when we substitute variable x, which is with the negative 3, so we get the remainder, which is positive 4. In this case, yes, the remainder is positive 4. Right? That's basically how to use the remainder theorem. Alright, let's go to the second example. Suppose we have this. We want to divide x to the power of 3 plus with 6x squared minus 2x minus 5 with x plus 5. So let's just use the long division. So you have x squared, and then I divide and multiply by x squared to this, so x to the power of 3 plus with 5 of x squared, and then I have to minus, that one will become x squared minus 2x minus 5, and then I'll divide this to go to this, so I'll have x squared divided by x, we'll get a positive x. And then I want to go back to that, so I have x multiplied with x, I'll have a positive x squared. X multiplied with 5, I get a positive 5x. Right now I want to minus this one, so what will happen? So this will become negative 7 of x minus with 5. So negative 7 of x minus with 5, and divide again with x plus 5, you get. Alright, so you go back to this, and then you go here, will become a negative 7. Now I'm going back to that, so I have negative 7 multiplied with x, I'll have a negative 7x. Negative 7 multiplied with 5, so I'll have a negative 35. Therefore, this one I will get a negative 5 minus with negative 35, I'll have a positive 30. Alright, you have a positive 30. You know, if the question asks you to write the quotients, of course the quotient is given by x squared plus with x minus 7, which is here. What about the remainder? Of course the remainder is here, so you have the what we call Rx, which is given by 30. This one is the divisor, and this one is the initial polynomial, Px. Now, what if, right, the question asks you, without using long division, what is the remainder of this polynomial when it is divided by x plus 5? So, without using long division, alright, so you just need to find this using the remainder theorem. Remainder theorem. Suppose to find the remainder of this polynomial when divided by x plus 5, so meaning to say you have to find the f of a negative 5, because this is a positive 5, therefore you have to find the f of a negative 5, meaning to say that you have to substitute a negative 5 inside this polynomial. So let's try. Negative 5 to the power of 3 plus with 6 and negative 5 to the power of 2 minus 2 and negative 5 minus 5. You simplify this using your calculator, you get 30. So this is the remainder. Okay, you get the same as the one when using the long division. Alright, so you can use the remainder theorem if the question asks you. Right now, suppose we have example 3 here. Alright, so let's read the questions. Alright, we have the functions here, which is the polynomial, and x minus 5 is a factor of g. So find m using the factor theorem. We know that when using the factor theorem, in this case, because x minus 5 is a factor, so we can say that, right, when we, in this case g, that one is a polynomial gx. So we know that g of 5, because this one is negative, so we have g of 5 will become 0, because x minus 5 is a factor. That's the meaning, alright, using the factor theorem. So we know that g5 is equal to 0. You just need to substitute of the variable x with 5 inside this and equate it equal to 0. So you have 5 to the power of 3 minus 5 to the power of 2 minus m multiplied with 5, and then plus with 15. You get this one equal to 0. Alright, so let's just, alright, so this part is actually the g5 and this part is actually 0. Okay, I'm writing that way. Now you have to simplify this using our calculator. You get a negative 5m plus with 65. This one equal to 0. We have to solve for the value of m. A negative 5m will become a negative 65. M will be negative 65 divided by negative 5. We get a 13 here. Right? Okay, now you know that your gx is actually an x to the power of 3 minus 3x squared, alright, minus 13x plus with 15. Alright, that's actually the polynomial gx. Now the question asks you to find the long division, alright, to factorize gx completely, right? Alright, so we have to, you know that x minus 5 is one of the factor. Right now we use the long division, x to the power of 3 minus 3x squared minus 13x plus with 15. You divide with the x minus 5 because x minus 5 is one of the factor. So you divide x to the power of 3 with x, so you get x to the power of 2. And then you multiply back, so you have x to the power of 3 minus 5x to the power of 2. simplify this by minus. All right, so you have 0 here, negative 3x squared plus with 5x cubed, 5x squared, therefore I have a positive 2x squared. Now I bring this down, I have 13x, right? Okay, I have a 13x here. Now I have this one as positive 15. Now I divide again, 2x squared with x, so I have a positive 2x, and then I'll multiply back 2x, right? So I'll have 2x squared, right, minus with 10x. All right, and then you minus here, so this one will become 0. So negative 13 plus with negative 13x plus with 10x, therefore I have a negative 3x plus with 15. Right now I'm dividing with this x, so therefore I have a negative 3, right? For multiply back, so negative 3 multiply with x, so negative 3x, negative 3 multiply with a negative 5, we get a positive 15. Therefore you get 0 here, right? Why 0? Because you know that by the factor theorem, when x minus 5 is the factor, therefore the remainder should be 0, right? So now you can write back in terms of, you have the initial function which is px given by qx dx plus with rx. All right, you can write this. Now in this case, qx is actually, all right, so in this case p is actually gx. Qx is where is qx? So qx is somewhere around here. So you can write this as x squared plus with 2x minus with 3. You multiply with dx. Where is dx? So dx is the divisor. You multiply with x minus 5. X minus 5. Plus with rx. So what about rx? So what is the value for rx? 0. So plus with 0. The question asks us to factorize gx completely. Meaning to say that we have to factorize which part? So we have to factorize this part here. Can we factorize it? Yes, using the quadratic factorization. So when we factorize this, it will become x plus with 3, x minus with 1. The other part, which is x minus 5, plus with 0, we can ignore it. So this is the complete factorization, right? Let me highlight using the green color. The complete factorization for gx, right? So that's the answer. Okay, you can factorize completely here. Now, suppose we have example 4 here. We have px here, all right, given by this polynomial. All right, it says that px has a remainder 19 when divided by this. Therefore, we have to use the long division to find the value of q. Let's just divide px, which is 2x to the power of 3 minus 4x squared plus 2x minus q. The question asks us to use the long division, therefore we have to use the long division. X minus 3. Right now, we try to divide 2 with x, therefore we have 2x squared. You multiply back, you get 2x squared multiplied with x, you get 2x to the power of cube minus with 6x squared. Right now, let's try to simplify this. So this one minus, so from 0, negative 4 plus with 6, therefore I have 2x squared. I bring down this 2 plus 2x, I bring down minus q here. Now I want to divide 2x squared with x, so I'll have something like plus with 2x, right? Now I want to multiply back, therefore I have this one multiply here. This will become a 2x squared, that one will become minus 6x. Right now, this one becomes 0, so 2 minus a negative 6 will have a positive 8x minus q. Now I have to divide 8x with x, so I have a positive 8. Therefore, I want to multiply back. A positive 8 multiplied with x I have here will become an 8x, and that one will become 8 multiplied with a negative 3 I have a minus 24. Right. So now we want to simplify this. We will get something like this one minus. So 8 with 8 becomes 0, and a negative q minus of negative 24. So this is actually negative q minus with a negative 24. Or simplify it will be, all right, a negative q plus with 24. All right, this is actually, all right, this is the quotient. We know this is quotient. This is the divisor, and this is the polynomial px. And of course, this one is actually the remainder. We know that from the question, it says that the remainder is 19. So this is also the remainder. So remainder is 19, so negative q plus 24 is the remainder, and the question gives the information that the remainder is 19, so this can be equated to 19, right? So we have to solve this linear equation to find the value for q. So we have a negative q equal to 19 minus 24. I have a negative q which is equal to negative 5, therefore I have q which is equal to 5. All right, so we solve this problem. All right, and we are done. Right, what about if we have this type of equation? We have this, and the question asks us to use the long division to find the other factor if this is one of the factors. So we can divide this, gx with that factor. So I'll have something like x to the power of 3 minus 5x squared plus with 3x minus 15. So I have something like this. Okay, now I want to divide with x squared plus with 3. Now using your this, all right, so you divide x cubed with x squared. I have x, all right, I have an x, so I multiply by x with x squared, so I have x to the power of 3. I multiply x with 3, I'll have a positive 3x, so I put it here. Okay, positive 3x. Now I have to minus, so this part becomes 0, so this will, you just bring down, all right, negative 5x squared, and this one, because 3x minus with 3x becomes 0, so you just bring down and minus 15 here. Now I need to kind of divide this with this, so I'll have a negative 5x squared divided by x squared, we get a negative 5. Sorry, a negative 5, yes. So you have a negative 5 there. Now you multiply by negative 5. All right, now I'm multiplying negative 5 with x squared. I have a negative 5x squared. I'll multiply with negative 5 with 13. I have a negative 15. So this one will become 0. Right? Why? Because we know that this is the factor. Right? This is the factor of gx. When x squared plus 3 is the factor, of course the remainder should be 0. All right, so now we can write back. All right, so we know that gx or px, all right, is actually equal to qx quotient multiplied with the divisor plus with the remainder. So our quotient is actually here, x minus 5, so you have x minus 5 multiplied with x squared plus with 3, which is the divisor, and rx is actually 0. So this can be written as x minus 5 x squared plus with 3. That's the factor for gx. So we know that this is one of the factors. Of course, this one is another factor. Therefore, our x minus 5 is another factor for gx. All right, so we are done with this one. Now we are using the long division. There is another method which is actually easier for us to solve these kind of polynomial problems. We can use the synthetic division, which is I think faster, but you have to be careful with this one. Suppose we are asked to divide this with this using the synthetic division. So we can actually write the coefficient of each of term inside this polynomial inside this. So you just consider, for the x cubed, so 1. For the x squared will be a negative 2. For the x will be a negative 3. And for the constant is actually 4. Alright, so if you're confused with this one, you can write, alright, this one for x cubed, this one for x squared, this one is for the x, and this one is for the constant. Now you want to divide with x minus 3. You just take the number negative 3 here, so it should be a positive 3 here. Right? So you want to divide with x minus 3, I repeat. So you just consider a positive 3 here. Don't take a negative 3. Now, the first step is to bring down 1 here. When you bring down 1, you will have 1 here. And then what will happen next? You have to multiply 1 with 3, and then you will get 1 with 3. You want 1 multiplied with 3, you get a 3. And then, alright, okay, alright, 1 multiplied with 3. Now, you have to add these two. You go down, add negative 2 plus with 3. What will happen? Negative 2 plus with 3, you get 1. Okay, so we have something like this. Again, you have to repeat the process. 1 multiplied with 3. Alright, 1 multiplied with 3, you get a 3. So negative 3 plus with 3, you go down, you'll get a 0. Alright, so you have something like this. Okay, now you want to repeat again. So 0 multiplied with what do we call 3, right? You'll get a 0 here. And then 4, you go down, you have to add with 0, you get a positive 4 here. Alright, so that's how you use this synthetic division. Right, now I want to divide this part. Alright, sorry, divide this part, because the last part is actually the remainder, and this part is actually the quotient. And this part, each of these, alright, this one is the coefficient of x squared, this one is coefficient of x, this one is the coefficient of the constant. Alright, so if the question asks us to find the the quotient, suppose, so of course in this case the quotient is actually given by, alright, you consider this one. The coefficient of x squared is 1, therefore you have the quotient which is x squared. The coefficient of x is positive 1, therefore you have plus x. And the constant is 0, so I don't write 0, plus 0. What about the rx, the remainder which is given here, alright? So you get 4, positive 4 is the remainder, right? So we have something like this, alright? If you want to write the form of equation which is in the form of px is equal to qx dx plus with rx, so it will be something like this one will have qx is actually x squared plus with x, dx is actually dx minus 3, remainder is plus 4. You have something like this. Okay, alright. You can still factorize this, x squared plus with x. Okay, now we are done with this one. That's a simpler method to solve these polynomial problems, right? So synthetic division, but you can use synthetic division when the question asks you to do so, right? No. Okay, the question asks us to use the synthetic division to find the quotient and the value for p. If this has the remainder, this, right? Now we want to divide with x plus 2. So what we should do, we start with drawing this. Now writing the coefficients of x cubed, x squared, x, and the constant. Therefore you write 2, 1, negative 1, p. Where do I get this? From this, the equation here, the coefficient here, 1 and negative 1 and p. Right, now I want to divide this with x plus 2. Therefore, because this is x plus 2, so it will become a negative 2 here. Right, now I bring down 2 first, so I have something like a positive 2. 2 multiplied with a negative 2 will get a negative 4. Now 1 plus with negative 4, you go down here, so you'll have a negative 3. Alright, something like this. Okay, now a negative 3 you multiply with, alright, negative 2, alright, you multiply this, you'll get a positive 6, you're right here. And then negative 1 plus with 6, so 6 minus 1 will be a 5. Right? Again, you have to multiply with what do we call 5. Alright, 5 with negative 2, you get a negative 10 here. Alright, something like this. Therefore, p plus with negative 10, you get a p minus 10. Right, we should know that this part is actually the quotient, and this is the remainder. And we know that, alright, the question already gives us the remainder is actually a negative 22. So this is the remainder. So we write p minus 10, alright, so this is the remainder. So since the question gives us the remainder is actually a negative 22, we can write this is actually equal to a negative 22. right? We know that this is the remainder, right? This is the remainder, and this is also the remainder, so they are the same thing. So we can equate them. We can solve the value for p, which is in this case a negative 22 plus with 10. Therefore, we have a p which is given by a negative 12. So we are done with this question. It is simpler than the long division, right? All right. But you just need to be careful on solving this synthetic division. Right now, what if we have this one? We have the synthetic division. We have to use the synthetic division to divide this. All right. You need to find the remainder. Right. You can actually there are many methods to find the remainder of this polynomial when divided with that. But you have to bear in mind that if you want to use the synthetic division, then you have to use the synthetic division. But if the question asks you to use the what we call the remainder theorem, then you have to find it in this case. All right, I just write it here. If you have to use the remainder theorem, therefore you have to find the f of positive 3. Then you get the remainder. What is the remainder? But if you have to use the long division, you have to perform in this case, right? But now the question, there are many methods. And the third method, which is to use the synthetic division, where in this case, the question asks us to use the synthetic division. Therefore, I'm going to use the synthetic division here. So I have something like this. So this is the coefficient of x cubed, coefficient of x squared, coefficient of x, and the constant number. And I want to divide with x minus 3, therefore I have to consider a positive 3 only. So now I bring down 2, I have a positive 2. Now I multiply 2 with 3, I'll have a 6, right? You go here. So 6, you have to add with a negative 4, you have a 2, right? Something like this. 2 multiplied with 3, right? You go here, you get a 6 here. Therefore, 6 plus with 1, because because you need to go down, this way you add, okay, plus. So 1 plus with 6, you get a 7. 7, again, you multiply with 3, you get a 21. So negative 3 plus with 21, you get a 18. So we should know that when you have this is the constant, right? This is the constant, this is the coefficient of x, and this is the coefficient of x squared. And this is the remainder. Right now, the question asks us to find the remainder. So you just need the remainder. Rx in this case is a positive 18. That's the answer, right? Let me write here. Rx is actually 18, the remainder. Now, in the second question, we are asked to find the remainder of this when divided with this using the remainder theorem. We know that before this, when we have suppose we have this function, right? Suppose that is the function in the second question. I put it at fx, right, as the function of 3x cubed minus with x squared plus with 2x minus with 5. If we have the fact we divide fx with x minus 3, so to find the remainder, of course, we just need to find f of 3. That is the remainder. If the question asks us to find the when the remainder when the fx divided with x plus 1, therefore I have to find the f of a negative 1. But if the question asks us to find the remainder when the fx is divided with 2x minus 3, therefore I have to find the f of a positive 3 divided by 2. Alright, you have to modify this part. Right? So in this case, to find the remainder for this fx when divided with 2x plus 3, I actually need to find the f of 3 over 2 by using the remainder theorem. So you just need to plug in the value for 3 over 2 at the variable x. So I have something like 3 over 2 square, cube, minus with 3 over 2 square, plus with 2, 3 over 2 minus with 5. Therefore, I'll get the answer, which is the remainder as, a fraction, which is in this case 47 over 8. Right? So that's basically how to use the remainder theorem. Right? So this part is a crucial part here, where you have to know how to find the remainder when we know the divisor. Alright? Now, let's go to the last example here. we need to show that x minus 1 is not a factor of this one. How to show that it's not a factor? So we should know that we have to use the remainder theorem. By remainder theorem, we should know that if x minus 1 is not a factor, therefore we should say that f of 1 should not be equal to 0. Because if f of 1 equal to 0, then it is actually a factor. But now we want to show that it's not a factor, meaning to say that we have to show that f of 1 is not equal to 0. That's the part that we want to show. So we start by substituting the f of 1. Right, f of 1 in this case, you just need to plug in the value 1 at the variable x here. So you have 1 to the power of 3 minus 9 multiplied with 1 square plus with 26 multiplied with 1, you have minus 24. Therefore, you will have the value which is actually a negative 6. You know that negative 6, this is not equal to 0. So we've shown that therefore f of 1 is not equal to 0 by remainder theorem or by the factor theorem, alright? Okay, you can say that, alright, by factor theorem, alright? By factor theorem, right? By factor theorem, of course, f of 1, f of what do we call that x minus 1 is not a factor of fx. So you have to use the factor theorem, right? This is not remainder theorem, right? You have to use the factor theorem. All right, now we have to proceed with the next question, which asks us to use the synthetic division to find the quotient and remainder when the fx is divided by this. All right, let's just use the synthetic division. Very simple. Coefficient of x cubed, which is 1, coefficient of x squared, which is negative 9, coefficient of x, which is 26, and constant is actually 24 minus 24. You have to divide with x minus 1, therefore you have to put 1 here. And then bringing down, start with bringing down 1, therefore we have 1. And now multiplying 1 with 1, you get 1. So you have this one, negative 9 plus with 1, you get a negative 8. So now multiplying negative 8, you get here, which is actually negative 8 multiplied with 1, therefore you have a negative 8. Therefore you have this one will become 26 plus with a negative 8, therefore you have an 18 here. 18 multiplied with 1, therefore you have an 18. Right now you have to add the negative 24 with 18, therefore you have a negative 6. Bear in mind that this negative 6 is the remainder, and this is the part where we have the quotient. Therefore, because the quotient asks us to find the remainder in the equation, so qx is actually this one, and this one. So this is the coefficient of x squared, this one is the coefficient of x, this is the constant. Therefore we have x squared minus 8x plus with 18, and the remainder is actually a negative 6. So that's basically the synthetic division. So I hope you can figure out how to solve the polynomial, the division of the polynomial using the long division and the synthetic division. So that's it. Thank you for watching this video.